This is a revision session for OCR FP1. The topic is complex numbers, and the question comes from January 2010. It's question 8. So if we read through the question first of all, we're given a complex number a such that a squared is equal to 5 minus 12i. First part asks us to find to use an algebraic method to find the two possible values of a. And then in part 2, sketch on a single Argand diagram the two possible loci given by the modulus of z minus a equals the modulus of a. So we'll start by looking at part 1 first of all. So we've got to use an algebraic method to find a, in other words, to find the square root of 5 minus 12. So we're told that a squared is equal to 5 minus 12i. So we need to find the square root of 5 minus 12i. So let a equal, we'll say, p plus iq. It doesn't really matter what letters we use here, as long as we realise that p and q are real. So that means that if we know that a squared is equal to 5 minus 12i, then that tells us that p plus iq all squared is equal to 5 minus 12i. So we could multiply out the brackets on the left and we get p squared plus 2ipq minus q squared, remembering that I squared is equal to minus 1, and that is equal to 5 minus 12i. So the only way that those two things can be equal is that their real parts are equal and their imaginary parts are equal. So that means that p squared minus q squared must be equal to 5, and 2pq must be equal to 12. So if 2pq is equal to minus 12, it should be, then that means that pq is equal to minus 6, and we could say that p is equal to minus 6 over q. So effectively we have two equations, and we're really going to just solve those to try and find p and q. So I've rearranged the second one, p is equal to minus 6 over q, and I'm going to substitute that in to the first one. So substituting it in, then we'll have p squared will be 36 over q squared minus q squared is equal to 5. And rearranging that, we multiplying by q squared and bringing all the terms together, we'll end up with q to the 4th plus 5q squared minus 36 is equal to 0. We can factorise that. Q squared plus 9 upon q squared minus 4 equals 0. And that tells us that q is equal to plus or minus 2 so that means that p, well, if q is plus 2, then p will be minus 3, and if q is minus 2, then p will be plus 3. So I'll just turn those the other way around. And notice that I haven't bothered with the q squared plus 9 equals 0, because of course that would not give us a real solution. And we did say at the top p and q are both real. So we have q equals plus or minus 2, and p then will be equal to minus plus 3, which means that if we write those out, that means that a would be equal to 3 minus 2i, or a is equal to minus 3 plus 2i. So we have the two complex square roots of the complex number 5 minus 12i. Now, if we have a look at how the marks are awarded for this, and there were 5 marks, so let's just have a look at how the marks were awarded. We get up here a method mark for equating these two things. So there is a method mark here, and then an accuracy mark for getting your 2 correct results here, for equating the real and imaginary coefficients. You then get a method mark for getting your quadratic in Q squared, and a method mark for getting your values of P and Q, and an accuracy mark for getting your 2 completely correct answers at the end. So 5 marks in total for that part. So if we now look at part 2, we're then asked to sketch on an Argand diagram each of these 2 possible loci. So if we do that, then just bear in mind, so we have A equals, the 2 possibles were A equals 3 minus 2i, or we had A equals minus 3 plus 2i. So we need to look at those separately. So we'll start with the first one. So we would have modulus of z minus a would then become modulus of z minus 3 minus 2i equals the modulus of 3 minus 2i. Now the modulus of 3 minus 2i is going to be root 13. So remember, it's the square root of 3 squared plus minus 2 squared. So that's root 13. So we have got to draw a circle, centre 3 minus 2, radius root 13. So the important thing is you should be able to recognise this as a circle, centre A and radius mod A. So let's just see. So I've put the squared paper. Now you won't necessarily have squared paper, but I've just used it to try and help me draw a sort of freehand circle. So we'll mark the point 3 minus 2. So this is our imaginary axis and this is our real axis. Now it's root 13, and that is the distance from the origin to the centre. So just be aware that the circle is going to go through the origin. It's then going to have a modulus of root 13, so it's going to go through this sort of point. It's going to go through about here. It's going to go through over here. And I'm just giving myself a little bit of chance to try and get the accuracy of the drawing. So it's going to go in here. So I'm just going to try and draw the circle. And again, you know, the important thing is that you have a circle which has a radius, root 13, and it has the correct centre. So it's not a brilliantly drawn circle, but it has all the important features that we need. And similarly, when we do the second one, it's going to be z minus negative 3 plus 2i equal to, again, the same modulus, so it's going to be root 13. So this time we're going to have a centre at minus 3, 2, so its centre is going to be here, and again it is also going to go through the origin. So if again I just mark a few points just to help me try and draw it freehand. So we'll have a circle which looks a bit like that. Again, remembering it's going through the origin. So that will be our circle. Hopefully yours will be a little bit neater than that, but I think that will just about suffice. As I say, the important thing is that we have the correct features. So if we look at the marks for that, then we have B1 for having your circle at the correct centre, so you're getting just a writing showing it at the circle. You also get another mark for showing that it goes through the origin, so that's 2 marks for your first circle, and exactly the same thing for the second one, so you're getting 1 mark to show that it goes through the correct centre and 1 mark for going through the origin, so 4 marks. So 9 marks in total for question, 5 marks for the first part, 4 marks for the second. Don't forget that if you do want to watch more revision videos, then there are plenty available by going to the Further Maths Support Programme website.